All right, so it's me again, and we're going to continue with our review for the 7.5 to 8.2 test. This is really part 2 of this video. We're going to continue with the vectors. All right, so this first one just shows how there's different notation for the direction of a vector. So mostly in our word problems and everything, the direction angle will be with the horizontal. In other words, if you're thinking about it almost as like the unit circle or the coordinate plane, we always start with the horizontal in the positive x direction, right? And then we go around this way. So a degree measure with the horizontal is from that perspective. True bearing is when you start north, always start north, and you're going to go however many degrees from north in the clockwise direction. This one is always 3 digits. Okay, and then the quadrant bearing is when you either have an N first or an S first. So basically, if you think about the quadrants, 1, 2, 3, 4, if you have an angle that's going this way in quadrant 1, you're going to start north and go slightly to the east. If you have something that's in quadrant 2, you're going to start north and then go slightly to the west. If you have something that's in quadrant 4, you're going to start south and go slightly to the east. And if you're in quadrant 3, you're going to start south and go slightly to the west. Okay, so that's the way the quadrant bearings work. So 40 degrees with the horizontal, it's going to go up 40 degrees this way. Well, from due north, the true bearing, starting north, we would have to come down from north 50 degrees, because altogether there's 90 degrees in that quadrant. Oops, 50 degrees, what I meant to write. And remember, this is always 3 digits, so put a 0 in the front. And then the quadrant bearing for that same angle is starting north and going slightly to the east. So you start with the letter N, you're going to end with the letter E, and then you tell how many degrees it goes to the east. So 50 degrees east. Okay, so if we do the next one, the true bearing is 130. That means starting north, 90, and then past 90 to 130 degrees. So that's going to be the same, well, actually, let's do with the horizontal first, right? So from the horizontal, if you start here, if you go in the negative direction, you've gone 40 degrees into the negative direction. Or if you go the positive direction, and starting with the horizontal, you could go positive or negative. We could go around this way, and that's going to be 320 degrees. Okay? Quadrant bearing, since we're down in the 4th quadrant, we're going to start south. And then how many degrees from the south does it go up? So if we went 40 degrees this way, it's going to be 50 degrees to the east. Okay, now I'm just going to fill these in so this video doesn't get too long. And hopefully you can figure out why they are what they are. Okay. All right, so this section now, you're given the vectors drawn for you. You just have to kind of take notice of how many to the right and how many up each one goes. So the vector v goes to the right 3 and up 2. If we were going to write the component form of that, it would look like that. But for this section, you really don't need to use component form. You're just really copying the vectors the way they are written. V plus W. So I'm going to do the first one live here, and then I'll just put up the answers. Again, I don't want this video to get too long, but for V plus W, I'm going to copy V, which is to the right 3 and up 2. So 1, 2, 3, up 2. Put the arrow, make sure you're writing your arrow there, and that's vector V. Then I'm going to add W. So it's a positive W, so I'm going to copy it exactly how it is drawn, which is right 2 and down 2. So my V plus W resultant vector, I'll do in red, is going to be from where I started to where I ended, right here. Okay, and that is V plus W. Now, the magnitude and direction of this resultant vector is basically, we're going to use Pythagorean theorem whenever it's magnitude, and then the direction is always from the horizontal. Well, with this one, there's really no triangle I can draw because it's just straight horizontal. So the magnitude is 5. It just goes 5 units to the right. The direction is 0 degrees. From the horizontal, it doesn't go positive or negative direction at all. Okay, the magnitude for B, we're going to draw negative 3W. That means we have to reverse the direction of W. W goes up to the left 2 and up 2 is what we need to do if it's negative W, right? So it's the left 2, up 2, and then we have to do that 3 times. So negative 3W is going to look like this. Now, to draw the triangle here, we are going to see that this is 6 this way and 6 this way. So when we do the magnitude, it's going to be 6 squared plus 6 squared equals c squared. And this turns out to be 8.49, the square root of 36. Sorry, not the square root of 36, the square root of 72. And then the direction, when we do theta here, it's going to be the inverse tan, and we have to do 6 over 6. And it turns out that this is 45 degrees. Now, for this one, though, we have to remember that it's always from the horizontal. So this one is actually not 45 degrees. It's 180 minus 45 degrees, which is going to give you 135 degrees, because you always want the direction from the horizontal. Okay? And this one, we're going to do 2W minus U. So I'm going to start up here. That's 1W, 2W. Minus U, so we have to go the opposite direction of what U says. So here's minus U. And then the resultant vector from where I started to where I ended is there. Okay, and if we draw the triangle, it'll look like that. This is the theta we want, so that's why I drew my triangle in this direction. This is 3, and this is 7. So we're going to do 3 squared plus 7 squared equals c squared, and c is 7.62. Direction, we're going to do tan, inverse tan, of, so if this is our reference angle, opposite over adjacent is 7 over 3, and this is 66.8 degrees. And since it's going in the negative direction, I'm just going to put a negative there. negative from the horizontal. Okay. Now there's going to be sort of the calculation section of this. Determine the component and linear combination form of vector AB. Notice vector AB shows us that it starts at A and ends at B, so the terminal point is B. So when we find the component form using the initial and terminal points, we want to make sure we're doing terminal minus initial. So in this case, it's going to be B minus A. So to get the x coordinate of our component form, we're going to do 2 minus a negative 1. And then to get the y, we're going to do 7 minus 8. So 2 minus negative 1 is 3. 7 minus 8 is negative 1. So component form is 3, negative 1 with the little doohickeys like that. Turning that into linear combination form is easy. We just take the 3 and make it 3i minus 1j, so just j. And then the magnitude from that, again, magnitude is going to be Pythagorean theorem. So you're going to do 3 squared plus negative 1 squared equals c squared. And this is the square root of 10, or 3.16. All right, component form here, do the same process. And this is what you should end up with. Okay, find each of the following for W. We are going to, we're given the component forms of these vectors, and now we're adding or subtracting them. Sometimes there's a scalar that we have to multiply by. So for W minus Y, we're just going to say 2, negative 3 is W. And we're going to subtract Y. Y is just 0, 7. Subtract them. 2 minus 0 is 2. Negative 3 minus 7 is negative 10. And our answer should be 2, negative 10. All right, when we do for Z, we have to make sure we multiply everything in Z by 4. It's going to be negative 20, negative 8, and then minus W. And the W is 2, negative 3. So when we subtract these, we get negative 22, comma, negative 5. Because negative 8 minus a negative 3 is really plus 3. Okay, these answers are going to be negative 5, negative 19, and 9, negative 18. To see the worked out answers for those, you can look at Google Classroom and see the worked out solutions. Okay, find the component form and linear combination form of the vector with the given magnitude and direction. So now they're giving us the magnitude is 5 and the direction angle is 210. We're going to use our formulas for V cosine theta and this component form, and V sine theta. So when we're given the magnitude and direction angle, then we use this for component form. So this is just going to be 5 cosine 210, and then 5 sine 210. And this turns out to be negative 4.33 and negative 2.5. So that's number 12. Number 13 is 7 cos 315 and 7 sine 315. And we just plug that in and we get 4.95. You will have a calculator for the whole test. So you're just using your calculator there. All right, find the direction angle of each vector given either the linear combination form or the component form. Oh, I just realized that this one asked us for both forms. So for this one, the linear combination form would be negative 4.33i minus 2.5j, and this one would be 4.95I minus 4.95j. Okay, sorry. So now this one, find the direction angle. Remember, direction angle is always inverse tan. So in this case, we have a 1 here, and we have a negative 2 here. We're going to do inverse tan of 1 over negative 2. Now, just be careful here, because this is where you have to think about it as if this was moving in like from the origin. So think about kind of the coordinate plane or the unit circle. If you were going to move from the origin negative 2 and up 1, negative 2 up 1, this vector would be in the second quadrant. So when we do inverse tan, that's always going to give us a degree measure that's between negative 90 and 90. Remember when we did cos tan, right? The tan was always these two quadrants. So when we put this into our calculator, we get negative 26.6. That puts us in the fourth quadrant, negative 26.6. From the horizontal, that would be down here. Well, we know that this situation is not in the fourth quadrant, it's in the second quadrant. So we have to add 180 to get the equivalent tangent up in the second quadrant. So here we're going to add 180. And our final answer there is 153.4 degrees. Right? So now when we do, this one is in component form. Again, we're going to do inverse tan. And it's the y over the x, so negative 5 over negative 6. Again, when we put this into our calculator, it gives us a negative degree measure, negative 52.06. But this situation, negative, negative, back and down, puts us a vector in the third quadrant, not in the not in the fourth quadrant, which is where negative 52.06 would be. Sorry, my eyes jumped down to the wrong number. This 52.06 is in the next problem. I'm looking at my answer key and I looked down at the wrong one. This one, when we put it into our calculator, gives us 39.81. So that is actually in the first quadrant, 39.81, but we know that this situation is in the fourth quadrant, negative, negative. So again, we're going to add 180 to bring it into the quadrant that we need it to be in, and that ends up to be 219.8 degrees. Okay, so this next one is going to have that 52.06. Victor leaves his apartment and walks 45 degrees west of north for 1,000 feet. So we're getting into the word problems here for vectors. Again, this is the direction angle, this is the magnitude, and this is the magnitude, and it's due north. So that's the direction angle. So there's two vectors going on here. So vector 1 is the 1,000, and vector 2 is the 200. Now, I'm leaving space for the degree measures here because I'm noticing that west of north, this is not from the horizontal. And whenever we plug in this cosine theta, our theta has to be from the horizontal. So I got to think about this now. He leaves his apartment and walks 45 degrees west of north. So here's north, here's west. He goes 45 degrees to the west of north, this way. So from the horizontal, that's actually from here 90 plus 45, which is 135. So this angle has to be 135 for that one. Vector 2, he goes 200 feet due north. So if he's going due north from the horizontal, that's 90 degrees. So this should be 90 and 90. Okay? So when we calculate that, put them in as decimals, it turns out that V1 plus V2 is negative 707.11 and 907.11. So that's the component form. They're asking us for how far, so magnitude, and in what direction. So we have to do the two methods that we learned. Magnitude is Pythagorean theorem, and we're going to do negative 707.11 squared plus 907.11 squared equals c squared, and c turns out to be 568.19 feet. The other method we learned for finding the direction is inverse tan. And inverse tan is always going to be the y over the x, so 907.11 over negative 707.11, and we get, this is where that negative 52.06 comes in. Now, based on these directions that we're giving, he leaves his apartment, he walks 45 degrees west of north for 1,000 feet, and then he goes due north for 200 feet. So his path looks like this. So the resultant vector that we're finding here is in the second quadrant. So since we're in the second quadrant, and we just got an angle of negative 52 down here, again, we have to add 180 to get our final answer. So our final answer here is going to be 127 point, geez, I can't read it, it got smudged, 127.9, I think it says. Yeah, that makes sense, because round to 0.1, yeah, okay. That's the direction. Okay, Allie is pulling a crate of construction materials with a force of 60 newtons at an angle of 42 degrees with the horizontal. So this one is with the horizontal already. Here they're just asking to draw the diagram and then find the magnitudes. So they're of the vertical and horizontal components. There is only one vector here. She's pulling a crate at this magnitude and this direction. Okay, so there's only one vector. So we're not going to need to add them or do Pythagorean theorem with them. We are just plugging in to our this horizontal and vertical components is all we need here. So our diagram is going to look like this. 42 degrees, and she's pulling 60 newtons up. Okay? So the magnitudes of the horizontal and vertical is just going to be 60 cosine 42 and 60 sine 42. So horizontal is 44.59, that's our x, and vertical is 40.15, that's our y. Okay, suppose Cam pulls on the ends of a rope tied to a dinghy in the water with a force of 50 newtons at an angle of 60 degrees with the horizontal. Again, only one vector going on. Same idea here. Force of 50 newtons at an angle of 60 degrees. 60 degrees, 50 newtons along here. Okay, show the horizontal and vertical components there as a triangle. Okay, so the magnitude for this is going to be 25 for the horizontal and 43.3 for the vertical. Again, same process there. Number 19, a helicopter is moving 15 degrees east of north with a velocity of 52 kilometers per hour, and then there's a wind blowing. So now we have two vectors. So this is one where we're going to have to add the vectors. So we have vector 1 and vector 2. Vector 1 is our helicopter, 52 cos. Again, I'm going to leave a blank because I got to figure out exactly how to express that angle from the horizontal. Not sure it's from the horizontal. It's actually east of north, so it's not. Okay, and then I'm going to leave a blank for that one. And then the vector 2 is the wind. It's going to be 30 cosine blank and 30 sine blank. Again, I got to fill in those blanks. So let me think about this. I've got my helicopter moving 15 degrees east of north. Here's north, going to the east, 15 degrees. Well, from the horizontal, I gotta go this way, that's 75 degrees. That's vector 1. Now the wind is my vector 2, is blowing 35 degrees west of north. Here's north, here's west, 35 degrees west of north. Well, from the horizontal, that's 90 plus 35, or 125 degrees. Now, we plug those into our calculator. We're going to get our decimal equivalents, 13.46, etc. All these get decimals. We add them. We end up with negative 3.75 and 74.8. We're not done, though, because they're asking us for the velocity and direction. So speed and direction here. Velocity, that's the magnitude or the speed, is going to be Pythagorean theorem, like always. So negative 3.75 squared plus 74.8 squared equals c squared. And c is 74.9 kilometers per hour. And then the direction is inverse tan, like always. Once you have this component form, depending on the question they're asking, you're going to be doing Pythagorean theorem and inverse tan for magnitude and direction. So y over x, 74.8 over negative 3.75. And this turns out to be negative 87.13. Again, we got to think about this. Are we really in the negative 87 direction? I don't think so. Because if this helicopter was flying this direction with the wind blowing this way, he's not going to end up down here. Not going to happen, right? So that would be negative 87.13. So we have to get the equivalent direction angle in the correct quadrant. Okay, so figuring that this is 87.13 degrees, that's really close down here. This helicopter is getting blown into the second quadrant here because it only starts 15 degrees this way, and then there's that strong wind blowing it. So it's going to end up here. So we need to take our negative 87.13, again, add 180. and that ends up 92.87 degrees from the horizontal. Okay? All right. Golf video game. Greta hits a ball 35 degrees above the horizontal at a speed of 40 miles per hour. So again, we've got 40 cos 35. This is with the horizontal, so I don't have to worry about changing this one into a different angle measure than they give me, because they're giving it to me with the horizontal. And this wind is blowing from the west. In other words, it's heading east. You can see the direction right here of the wind. It's heading towards the east, straight in the horizontal direction. So it's a 5-mile-an-hour wind. Cosine, well, the degree measure from the horizontal of that is just 0, right? And then 5 sine 0. And 2 vectors, so we have to add them. This ends up 37.77, 22.94. Again, we need the speed and direction, so we need Pythagorean theorem and inverse tan. So Pythagorean theorem is this squared plus that squared plus c squared, and that turns out to be 44.19 miles per hour. And then the direction, inverse tan of 22.94 over 37.77, and we get 31.27 degrees. And since this was all from the horizontal, and it is a logical direction, right? If we think about this ball in this quadrant, that makes sense. Okay? So, Gus and Connor are going skydiving if they leave the plane with initial velocity of 12 meters per second at heading south 47 degrees west. Okay, so we're starting south and we're going 47 degrees west. So this vector is down this way, and from the horizontal, we're going to have to come up with the degree measure all the way to here, right? So if that's 47 degrees, that means this little piece here is 43 degrees. We add that to 180, this turns out to be a total of 223 degrees. So our vector 1 is 12 cos 223, 12 sine 223. Our second vector is the wind speed is 2 meters per second. Here's the wind. North, 27 degrees west. So this way, 27 degrees. Well, if that's 27 degrees from the horizontal, we have to go from here and do 90 plus 27, and that is 117 degrees from the horizontal. So this is 2 cos 117 and 2 sine 117. Negative 9.69, negative 6.4. Again, we've got our component form. We have to do magnitude and direction. We're going to do Pythagorean theorem, and we get 11.6 meters per second for magnitude, and we do tan of negative 6.4 over negative 9.69, which is 33.44 degrees. Think about the logic of this, right? This is our vector, this is the wind. This is not going to end up here. Hopefully, if you're skydiving, you're not going in a vector that's going up and to the right. That wouldn't be a good direction for skydiving. So, again, we're going to have to add 180 to get this into the right quadrant. And that's going to be 213.44 degrees from the horizontal. Okay, I hope this helps you guys.